Welcome back. In this tutorial, we will focus on the Kinetic Changepoint tool. This tutorial is based on the previous tutorials, and let's make a molecule archive and let's calculate the variance. I would recommend you to follow along with those tutorials, or if you want to start right away, get a copy of the archive on the GitHub repository. As a reminder, in this tutorial we tracked polymerases on DNA. We first start with a short introduction to the Kinetic Changepoint algorithm. For more in-depth information, I refer you to the publication and our documentation section, which will be linked in the description. The algorithm is detecting change points. Those changes can be obscured by noise, which makes the changes hard to spot. For example, a typical type of noise on the molecular level would be thermal fluctuations. There is no filtering step or binning necessary. The algorithm uses only very few inputs, which makes it less biased. Furthermore, you don't need to assume a predefining model. We assume that the trace is piecewise linear between the change points. The underlying noise model is Gaussian distributed. We do not assume a specific kinetic model. Our input is the position versus time. Take the coordinate you are interested in, like changes in the x, y, or z direction. Keep in mind that your input will define the final unit. For example, if you have the position information in nanometer and the time information in seconds, you will get nanometer per second. The second input is the likelihood ratio or false positive rate. This will prevent overfitting of the data, and you can input the noise level. What you will end up with is a linear fit between your change points. The fit contains all the information you need from a linear fit. The slope is equivalent to the rate. Quick disclaimer: the kinetic change point is not suitable for non-linear data. Keep that in mind. Let's start with the actual tutorial. We open our archive, which we created previously. Go under Plugins, Mass, KCP and select Change Point Finder. Now a window will open. In case you have multiple archives open, select the one you want as an input. Select the time column for the X column, select the position column in the Y column. Select your confidence interval. 0.99 usually works fine. Global sigma is for your noise level. The next checkboxes are not selected. We will use them in a later example in this video. Here you can select the background as an input or a region as an input. You can also fit steps by selecting the Fit Steps, Zero Slope box, for example to find pauses. We only want to analyze the active molecules, so we select Tagged With and say which molecules we want to analyze by selecting the tag Active. We press OK. We will end up with another table in the Mars rover. When we select it, we will see the following. Each row is one fit for a line in between change points. x1 and x2 is the start and the end time, while y1 and y2 represent the start and the end position. We have the line equation of y equals b times x plus a, so b is the slope and a the intercept. We can also display the results in the plot of the traces. We select the segments and then hit refresh. We can take this now to the next level. In the example, we only saw one simple transition most of the time. The next example is to demonstrate the real power of the kinetic change point. For that, we download another archive from the GitHub. It is called testvideo_archive_kcp_complex.yama. In this example, we will also select a region of interest and a background region. We will go ahead and mark the regions accordingly. First, we mark the background. For that, we select the region tool and mark the first part of the trace. Just click where the region should start and drag the rectangle until the end of the region. Then we use the same tool to mark the active part of the trace. We can rename the regions by clicking on the name and type the new name. Background we call background, and the region of interest we simply call region. Now we can open again the Change Point Finder tool. We select everything accordingly. We need to select the correct archive. Since we have two archives open, we need to select the KCP complex one. Then select capital T for the time and nucleotides for the Y. Now we tick the box to select the background region and write the name of the region, in this case background. Then tick the box for analyze region and write region. We named it like that in the step before because of convenience. We click to include all because we have no text this time. Now let us have a look again at the results of the analysis. You can now see the separate fits. Also, our table now has multiple change points, or fits, for the piecewise linear parts of the trace. Don't forget to save your progress. In this tutorial, we used the Kinetic Change Point tool to fit the rates of the polymerases. For more details, check out our website. Thanks for watching.